So we're going to look at this question here, kind of the reverse of what we just did. We had just taken an equation and graphed it. Instead, what we're going to do is we're going to have, so creating an equation from an existing graph, okay? So this is sine or cos. We actually don't know which one it is. So we can actually technically make an equation for each of these from this graph, okay? It's sinusoidal. We're going to have to estimate our key points here. Whoops. That's good. I'm going to say that that's 0, 0, I think. Okay. It looks like the peak, and I probably could have, is going to be, what the heck number is that? I wouldn't even say that's the peak. I think it's about 360-ish, okay? I'm going to say it's at 360 and 2, 3, 4, and about 4. Okay, so we are estimating, and I'm trying to use numbers that I think would be relevant to what we're doing. We tend to, when we're working in degrees, work in that like 90, 180, 270, 360 range, or like 45 degrees in between. It starts to get really difficult if this was like 355. That becomes really hard to work with these numbers. So I've estimated that it's there. Another value here looks like it's at about 720. So right away, I'm thinking the period 720 degrees. Okay? Okay, that's going to be important for us. This is also a minimum. This is also a minimum. This is a maximum. So I got to figure out, like, where's the equation of the axis? I've kind of estimated there. So before we start going through all of that, let's write this out. Y is equal to A sine K of X plus D plus C. And the same thing goes for cos. I'm going to start with sine, and then we'll see if we can apply it to cos. What we're going to do is we're going to try to figure out, just like when we were applying it, and I made the mistake of doing it opposite, we should try to find the stretches and the compressions first, then they call them phase shifts. It's the shifting the entire equation without actually manipulating how that equation really looks. So, we talked about it already. What's the period? Well, it looks like it's going to be 720 degrees. Okay, so if it's 720 degrees, well, normally a period is 360, so I need an equation for this. So we talked about an equation. We can say that the old period divided by k is equal to the new period. Okay, well, the old period is 360. We know that if we're talking about sine. We're unsure what k is, and it looks like the new period is 720 degrees. Do you agree with that? Okay, so we've got to isolate for k. I can bring k over. That would give me 360 is equal to 720k. And if I bring 720 over, it gives me 360 divided by 720 equals k. Well, if I divide those, it actually becomes 0.5, or known as a half. So it looks like k is a half. And we talked about this. If k is a half, the period is elongated. In fact, it's twice as long. That makes sense. 360 times 2 is 720. That makes sense. Our k is half. Great. Now, I know we want to find the amplitude, but it actually is easiest to find the equation of the axis, which we actually also said was the vertical phase shift, and then find the amplitude. Well, how do we find the equation of the axis? It's actually easy. If we just take the max value and the min value and find the average of the two. So, let's see. So if I say, here's an equation. Max,
plus min.
Yeah, plus, exactly. Divided by 2. So what's our max? 4 plus 0 divided by 2. It's going to give us 2. So our C value is positive 2. Great. Now that we have that, positive 2, what's the difference? How far is it from 2, and I think this is 2, to the max and the min? Well, this is pretty simple too. Literally just take the max, subtract it by the, not the min, actually from here, the equation of the axis, and vice versa. So I'm going to, for A, and the reason we do both is just to make sure we got the right number. So max subtract EOA, equation of the axis, okay? So 4 subtract 2 is 2, and the min subtract EOA. Minimum is 0, subtract 2. And now it's negative 2, but we're talking absolute value. Great. So it's 2. So the amplitude is now 2. Great. Has there been a phase shift here? So we got to figure this out. Has there been a phase shift? The way to find the phase shift, if you remember with sine, sine is actually on the equation of the axis. That's where it starts from y. It's actually on the equation of the axis. So because it's on the equation of the axis, it normally goes down after, but it looks like this is at a minimum value. So if everything has been stretched and compressed here, we have a value at about 180. It's hard to see here. But 180 is normally where it would have been starting, okay? Now we said everything's been elongated by 2. This is really one of the hardest ones to find, and we can try to do it visually, and I could tell you, look, it's 180, but remember we stretched by a factor of 2. So we technically would take half of that, and it looks like it's half of that would be 90, so our phase shift is 90. That's a very visual way of trying to figure this out. Another thing we can do is if we can just figure out a point, like a max or a min, and compare it to an old max or a min that we think is equivalent, we can use a formula to find this last one. So if you recall in sine, one of the maxes, or at least the first max, and let's say this is the starting point here. The first max is, in this new equation, is 360 and 4. Well, in our original, it would have been 90 and 1, okay? We can use these two sets of coordinates to actually find all of these. So we did it visually, and I showed you some small formulas, but I'm going to show you the formulas that work every single time, okay? D is really the hardest one, and that's why I introduced these formulas after. There's a little formula that says the new x value, so I'm going to put an n for new x value, is equal to the old x value times, divided by k, and technically subtract d. I know it says positive there, but we subtract d. Same thing goes for the new y value is equal to a times the old y value plus c, okay? Because we've got a bunch of this information from viewing it, from the periods and stuff, we can start to figure these things out. D is the only one we're missing, so I'm going to figure that one out now, but we can technically apply it to the other ones. The new x value, well, the new x value is 360, and the old one was 90. Great, so let's use this little formula here. Can I shrink these? Oh yeah, I can shrink it a little. Move it to that corner and give me some room. Okay. So our new x value was 360 is equal to 90 over, well, we actually already figured out k. It's divided by a half. Now it's going to be a little tricky. Subtract d. Oh, we just got to isolate for d. Top of a fraction divided by half is the same as multiplying it by 2. Okay, I'm just going to show you that as a shortcut. So what does that mean? That means, great, 180 minus d. We bring 180 over, we get 360, subtract 180.
Which is 180.
Yeah, is equal to negative d, and is equal to 180. That's okay. Which is negative d, which technically means negative, yeah, 1 second please. Negative 180 is equal to d. Negative 180 is also the equivalent of positive 180. All right, a phase shift of positive 180. Yes, that's correct. So then we can go and double check that we've got the right answer here. Let's go to our control center. So I went to check it out, and the only thing that I've left out is that there should be an extra bracket in here, but that is the correct amount. I'm sorry, here, d is equal to negative 180. So when we go to write this in, this would be negative 180, but since this should be a subtraction sign, it ends up becoming plus 180. So how does this equation eventually look? So it becomes y is equal to 2 sine, and we have our first set of brackets, k was a half, then we have our second set of brackets from within, x plus 180, and then we end both sets of brackets plus 2. And I actually created this in Desmos. So it should be, did I write negative 180 in there? Or did I write positive? Whoops, sorry. It is negative 180. And here it is in Desmos. I'll take that one away. Here's our horizontal line going through 2. We can create some vertical lines just to prove our points are correct here. X is equal to, let's say 360. There's a coordinate 360 and 0. We know that this one here is a starting point, 0, 0. Another one is 320, 720 and 0, 540 and 2, and 180 and 0. There we go. We got all of our wonderful points. So that actually works out great for us. Okay.